So what is happening friends? With the increase in randomness, there is increase in entropy, because with increase in randomness there is increase in disorderedness, and simultaneously because of that entropy increases. So if the change from initial to final results in increase in randomness, there is increase in entropy. So what does that mean? Final entropy minus initial entropy is greater than 0. So that's why delta S greater than 0. Let's consider an example. If you consider a solid state, consider an ice for example, which is solid. If you heat it, it converts into liquid, and if you heat it further, you will get gas. So what is happening? For any substance, the solid state is more ordered. So here ice is more ordered than liquid state, right? And liquid state is more ordered than gaseous state. And what happens simultaneously? Solid will be having less entropy than liquid, and liquid will be having less entropy than gas. Right friends? So you can see here gas has more entropy than liquid, and liquid has more entropy than solid. And another important point, friend, we have already discussed this. Second law of thermodynamics gives me an idea about entropy of the universe for reversible process and also irreversible spontaneous process. We have already discussed that for reversible process, the total entropy of the universe is 0, and for irreversible process or spontaneous process, just like rusting of iron or decomposition of apple, the total entropy of the universe is increasing. That means final entropy is greater than initial entropy of the universe. So entropy of the universe is increasing, right? Important thing is friends, entropy can also decrease for individual system. Let's see the implications, how it happens. All right. And if the number of particles increases in a given system, that leads to increase in energy. For example, gas has more number of particles than solid, right? So that means entropy of gas is greater than entropy of the solid, right? So what does that mean now? More number of particles, more is the entropy. Now another important parameter, what happens if you increase the temperature? The same example we have discussed, solid to liquid, liquid to gas, there you are increasing temperature. So what is happening friends, if you increase the temperature, there is increase in the disorderedness. That means there is increase in entropy. So higher is the temperature, higher is the entropy. And structure. Here you might understand that solid is highly structured, right, compared to liquids and compared to gases. So gas, which is less structured compared to solid, it has more entropy. So higher is the structure or stronger is the structure, lesser is the entropy. So this is what the important implications of entropy with different factors like particle number, temperature and structure. Hi friends, so for any further doubts you can open askIITians.com and you can find the discussion board, and if you click on it, you will get Ask Experts on the right side of the screen, and you select the category accordingly. So thermodynamics belongs to physical chemistry, and you can post your question here. We experts at askIITians will be reverting you back within 24 to 48 hours. So friends, in this part we have discussed how different number of particles, temperature and different states of matter plays an important role in determining second law of thermodynamics. So in the next part we will discuss some more interesting points. So keep tuned friends, have a good day.